Got it? So while this stuff is booting, I'm gonna kind of just start the chat. Do we have like any like content creators or any kind of like, like, do you guys like make stuff like either digitally or, like what kind of talents do you guys have? I'm just curious. You don't have to, because like one, I do need help. Like I'm looking for somebody, like I need to create like a logo, an intro and an outro, just learn how to do that. I haven't really tried. I really just been using YouTube as like a catalog to like hold like sessions and things. I'm just using it as like a library, but I haven't really tried. Let me share my screen. It was, I'm just curious. Let me get the student. Hey, Mr. Wilson. Right here. Okay. And we'll start here. Let me see as far as announcements go. So guys, we are in that home stretch, right? It's pretty much over, right? So I hope everyone is doing well, So we're meeting today. We're not going to meet on Wednesday, right? So it's the holiday week. So hopefully you have your travel plans and you could, you definitely want to maximize the time with your loved ones. I just have to mention the whole Shankola Robinson thing. That thing hit hard. I was like, ooh, there was one night I was up and I was just like scouring, looking for the second video. But I just send them love and light and, they are my hearts. That's tragic. Like I don't know if you know that story, but it's where this 25-year-old girl like went on a, attractive and this, that, and the other. And she got these like she's an entrepreneur. She seemed pretty successful. And she like went to Mexico with like some quote unquote friends and they essentially murdered her in Mexico. I was like, Jesus. And it's a tragic story. It's really, really tragic. And it's one thing, it's tragic. Like I'm thinking like one person was like, well, why haven't they have plenty of evidence. They have them on film doing it. It's like, why haven't they been arrested? And then, I guess it's this thing, they have to be like extradited. Because it happened in Mexico, they have to like, the process has to start with Mexico requesting them. And then, you have to go through the judicial system. I'm like, man, this realm is wild. It's wild to me. But yeah, I just send them a lot of love and light. Let me see. So as far as shifting gears, I know that's, but let me see. So as far as we're concerned, so we basically have 3 sessions remaining. We have today. We're not going to meet on Wednesday. That's obviously, school closes at noon, so I'm not going to make you guys come on. And then, so we have our holiday break. When we come back next week, we're going to meet Monday and Wednesday. So November 30th, that's the last time that you're required to attend, right? So then that Thursday and Friday, which is December 1st and 2nd, that's the reading period. So you shouldn't be meeting in any of your classes. I want to say our final exam becomes available that Sunday, December 4th at 11:11 a.m. And you have essentially 5 full days to get it submitted. Unlimited attempts, just like our other exams, but everything locks out that Friday, December 9th at 11:59 p.m. So what I was thinking that during the week of finals, even though you're not required, I'm not taking attendance, so you're not required to be in attendance, but I'll probably just make myself available during class time on that Monday and Wednesday during the week of finals. So just if you just wanted to pop in, if you had questions or anything, I probably will be gaming. Just get my attention, and I'll I won't be able to pause it, but I'll adjust to whatever. But yeah, but I'll just try to make myself available on that Monday and Wednesday. Just be on Zoom and just kind of look out for requests or questions or anything. And if you just have like any last minute questions that you have, or if you need anything cleared up, I'll be there. I intend to be there. So, if you are going back to improve your overall grade, I would encourage you to prioritize your old exams. You still get unlimited attempts at them. The system is set to take your highest score, so you have nothing to lose and everything to gain. You definitely want to prioritize the exams, as that's where you're going to get the most bang for your bucks, because the exams count for nearly 80% of your overall grade. The last thing you want to prioritize is the old homework, because that's going to be a lot of work for minimal points, so you won't see your grade shift. And also, hopefully you guys have been in communication or collaborating with Dr. Lamar with the lab component. I think you can see your lab grade on Blackboard. I think she already has that set up. And then all I'm going to do is take whatever grade is there on Blackboard, and I'm going to incorporate it into your overall grade. I'm going to scale it so that it counts for 10% of your overall grade. Okay. So what we do together is 90%, and her contribution, her portion is 10%. Okay. So then my thought process, I was like, okay, well, since we have 3 meetings remaining, I was thinking that each day we'll just take that day to review an exam. So today we're going to take as much time as we can to review exam 1. Okay. Let's see something really quickly. Oh yeah, let me check here. Okay. Okay, you guys are good. Okay. Oh, let me check one other thing. Right here. Okay, looks healthy so far. Okay, well, so with that, let's go ahead and take some time and go through so I have exam 1 loaded here, and we'll just get through as many questions as we can. Let me turn this. It says determine whether the 3 points are collinear, right? So co meaning together or with, and linear or same, and linear meaning line. So we want to determine if these 3 points are on the same line. So you can use like there are two methods here. One is I think called like the triangle inequality, where basically you find the distance between all 3 combos. Like if you have points A, B, and C, you find the distance between A and B, you find the distance between B and C, and you find the distance between A and C. And then if they're on the same line, the distance, like distance 1 plus distance 2 should equal distance 3. If distance 1 plus distance 2 equals distance 3, that means that, they're all on the same line. The way I prefer to do it, find the equation of the line between 2 points and then confirm whether the 3rd point is on that line, right? So I'm going to do the latter, where I find the equation of the line between the 2 points and then confirm the 3rd point. Let's see. Screen. Come on, thank you. Now, I usually like to try to keep the labels so you know where this is coming from, if you ever were to reference it. Okay, I'm gonna hit done, and I want to copy and delete. I'm gonna hop over here. I can just paste the image, allow the paste. Looking good. And as always, if you have questions, if anything is not clear, if you have questions, feel free to unmute yourself to get my attention. And we don't have to do the questions that I'm doing. I'm just, like I said, I'm just filling the air with content, things that are relevant to what we've been working on all this while. Okay. So let's see. So yes. Somebody had a question? Okay.
Yeah, it was Devin. He said that he's trying to join right now.
Okay, let me see. Okay. Let me get these 2 notes. One. Yeah, he looks good. I guess it worked. Yeah, I got him. And this one. Let him in. Cool. All right. So, hopefully you have a formula sheet, or you have some way, you know how this is kind of set up. So equation between 2 lines, there's 3 things actually that pop up. Whenever I'm working in lines, there's 3 equations or formulas that I think are good to have ready to go. The first one I want to highlight, let's highlight the slope formula. Slope formula, all right? So the slope between 2 points, so the slope is going to be the change in y over change in x, or rise over run, which is y2 minus y1 over x2 minus x1, right? Then we have the point slope formula. So point slope formula. You use this when you want to find the equation of the line when you're given a point and a slope, right? So that's going to be y minus y1 equals m times x minus x1. And hopefully you can notice the similarity between the slope formula and the point slope. If you multiply both sides by this denominator and drop the 2, right, then you get the point slope formula, right? So if you drop the 2, okay. And then the last one that I think is good to have is the slope-intercept formula, okay? So then that's going to be y equals mx plus b, right? So if whenever I'm working with lines, I just like to have these 3 ready to go, and I flow between them as needed. So for this example, I personally like to start with we need the slope formula, right? So then the slope, and I'm going to do the first and the third because those numbers just look easier to manage. So, and I'll go like this: x1, y1, x2, y2, right? So then when I go to plug them in, our y2 is 6 minus our y1 is -4 over 2 minus 0, okay? So then we basically get 10 divided by 2, which is 5. So we have our slope. So then I like to move, the next one I like to flow to. We could do point slope, and that's fine, but I like to go to the y equals mx plus b, okay? So we have our slope. I'm going to plug in, and we actually have the y-intercept, because when x is 0, y is -4. So they already gave us the b is -4. So we actually have all we need. So then our line is going to be y equals 5x minus 4, okay? So now our claim is that this is the equation of the line through the points, and we're going to test the third point. So now we just want to go back and confirm that all 3 points work, confirm or deny whether all 3 points work, okay? So let me see. If we can test 0, -4. So notice that y is going to be equal to 5 times 0 minus 4, which is equal to -4. So that one checks out, okay? Let's go ahead and test 2, 6. Thank you. Stop. Okay. So then y equals 5 times 2 minus 4, which is indeed 6. So that one checks out because that's what, 10 minus 4? Okay. And then so now the meat and potatoes, we want to see if -13, -19 is on this line. So the -13, -19. Okay. So then we're going to say something like y equals 5 times, I said -13. I'm definitely in holiday mode. Like, I am not thinking, I'm just trying to wrap everything up. Let's see. That's looking pretty good, right? Because you get -15 minus 4 is indeed -19, all right? So that one checks out as well. Okay. So then now we can, with confidence, are these 3 points collinear? We can say yes. So we're going to submit yes. All right, and on to the next question. So we won't really know how we did until I submit, and we'll just check whichever ones we've done. Identify the triangle as isosceles, equilateral, a right triangle, scaling. So isosceles is a triangle that has 2 equal sides, all right? Okay. Equilateral means they have 3 equal sides. A right triangle has a 90-degree angle. Scalene is a triangle where with 3 different sides, that all sides are different lengths. Okay. So this is basically a question on the distance formula. They want us to find the distance between all these 3 points and then compare and contrast, right? It's a little bit of a pain, but that's what they're asking. So the only way you're really going to know is to find the distance between the points. Now, I'm sure there's a quick way to do it in like the calculator, especially a graphing calculator. I don't know it offhand, but it's okay. I'm just going to crunch it here. Paste. Allow. Okay. So the distance formula, distance between 2 points, is another formula that's good to have handy. So the distance between 2 points P and Q, x2 minus x1 squared plus y2 minus y1 squared. Okay. Okay. So then that's essentially what we're going to be using. Let me do like this: x1, y1, x2, y2. Okay, and I'll find the distance between P and Q first. So then that's going to be -2 minus a -2. Okay, so that makes that easy. Squared plus -7 minus 1 squared. Okay. So then that's going to be -8 squared. I think that result is just going to be 8. Because this guy goes to 0, right? And then 8 squared, and you take the square root of 8. I mean, you take the square root of 8 squared is 8, all right? Okay, so we did PQ. Let's go ahead and do QR. So I'm gonna just shift this. If it lets me, it's not gonna let me. Let me see. Okay, I think I can get it if I go like this. Yeah. So let's do, QR. I'm gonna have to move it a little bit. Let's go like this. So I'm gonna let this be my x1, y1. This will be my x2 here. This will be my y2, -3. Okay. Okay, so what's the time? We're doing what, QR? Okay. X2 is, we got this -2 plus 4 root 3 minus, it's gonna be minus, okay, let's just write it. Okay, squared plus y2 is -3 minus a -7 squared. Okay. So I think the most challenging thing with this one is just keeping track of the signs. Let's see, double negative becomes positive, so these two cancel each other out. Okay, when you square it, you're gonna get 16 times 3, which is 30 plus 18, which is 48. Okay, so that first one becomes 48. 7 minus 3 is 4, so that's gonna be plus 16. Okay. 58, 64. So then I think that's also 8. Okay, so it's at least isosceles. We got 2 of the sides have a length 8. We need to do one more. We did PQ, QR, so we need to do PR. Okay. So then R can stay. This one like that, okay? So then our x2 is this -2 plus 4 root 3 minus our x1, which is -2. Okay, so that's kind of a repeat, but that's fine. Quantity squared plus our y2, -3. That's what, minus a -7? No, minus 1 squared. Okay. And I think we get some repeating results, right? Because these two guys cancel. So then 16 times 3 is 30 plus 18 is 48. So we've got another 48. And then that's 4 squared is 16, and we got another 16. All right. So then that means we get 8 again. So that means that all 3 sides had a length of 8. So that means we should be working with an equilateral, right? So I don't know if you heard me wince, like when I first got to this question, because the distance formula can be a pain, but you know, that's essentially what they wanted you to do. So we're gonna go equilateral, because we got all 3 sides were the same. Is it a right triangle? We're gonna say no. Now, to test it, in order for it to be a right triangle, it should be the case that a squared plus b squared equals c squared, but you're not gonna have an equilateral right triangle. Like you can't be equilateral and be a right triangle, all right? You're gonna have some other kind of shape. So once we had equilateral, then that stopped it from being a right triangle. Right? And we really should, I mean, and also in order for it to be a right triangle, it should be the case that a squared plus b squared equals c squared. So 8 squared plus 8 squared does not equal 8 squared, right? So it's not a right triangle. Okay, that's fine. Let's go on to the next part. Without sketching, find the x-intercepts. Okay, so the x-intercepts, I prefer to start with the y. I'm gonna start with the y. The y-intercept, you set x to 0. You could just look at it. When x is 0, you see the output is -8. I want it off. So right here, we're going to put -8. Okay. The x-intercepts, we're dealing with a parabola. Okay. You set y to 0. Maybe we should take some notes here. So we're looking for two numbers that multiply to give us -8 and add to give us -2. I think it's going to be -4 and +2. Right. So then that means that our intercepts are -2 and +4. -2 and +4. 4 plus 4 is 8 minus 8 is 0. 16 minus 16 is 0, right? So both of these, when you plug them in, create a 0 in the original. Okay. So we're just gonna go with that. We'll take about another 5 minutes. Test the equation for symmetry. Okay. So that brings me to two concepts. I'm using this more as an opportunity to just kind of touch on concepts. It's less about, I just want to try to touch on as many, dust the cobwebs off of as many concepts as I can. So if we're talking about symmetry, come on, right? So if we want to do a test for symmetry, you replace, like for instance, if we want to test for y-axis symmetry, then what we do is replace x with -x, and you simplify. If you get back to the original, then you have y-axis symmetry. Say we wanted to test for x-axis symmetry. All right, x-axis symmetry, what we do is replace y with -y. So when you replace y with -y and simplify, if you get back the original, then you have x-axis symmetry. Okay, and then the last is origin symmetry. Okay, and so for this one, to test for origin symmetry, you replace x with -x and replace y with -y, right? So you change both. When you change the both and you get back to the original, then you have origin symmetry. I want to say that if you have at least two of these, then you're guaranteed the third one, right? If you have two of them true within a function, then you're guaranteed the third one. But that also brings me to even or odd, right? Whether a function even versus odd functions. Okay. So even function, when we say a function is even, to test whether a function is even, what we do is we're going to evaluate f of, it's very similar. You evaluate f of -x. If you finish with the original, then we say the function is even. All right, this is the definition. So when you do f of -x, if you get back to f of x, that means the function is even. A function being odd, when you evaluate f of -x, you get a negative times the original. So if you replace x with -x, you simplify and you get negative times the original, then that means the function is odd. Okay. Even is the same as y-axis symmetry. Odd is the same as origin symmetry. If a graph has x-axis symmetry, then it's not a function. All right, so I'll put that like a caution or something, not a function. So if you have x-axis symmetry, that's not a function. Okay. So even is synonymous with y-axis symmetry. Odd is synonymous with origin symmetry. X-axis symmetry. If a graph has x-axis symmetry, then it's not a function. Okay. Since we're talking about concepts, that brings me to, let me kind of touch on the inverse of a function, right? So the following, I think it's like 4 phrases are synonymous, right? So when we say a function is 1-to-1, that's synonymous with saying the graph passes the horizontal line test. Okay. I just want to kind of mention up here the vertical line test. That tells you if a graph is a function or not. All right. Horizontal line test tells us, okay, let me see, passes the horizontal line test, which is the same as has an inverse, which is the same as, thank you. That's why I was misbehaving. Every y corresponds to exactly 1x. Okay, so these 4 phrases are synonymous. To show a graph has an inverse. Okay. Basically, what you have to do is, when you start with, if you equate 2 different y values, I'm going to say need to show that a equals b, right? So if you start with f of a equals f of b, and then you simplify, if you can get down to a equals b, then the graph has an inverse. But if you finish with a is not necessarily equal to b, then the graph does not have an inverse. And then the last thing to find, and I don't know if I'm answering this question or not, but to find the inverse, okay, to find an inverse, I'll try to keep it as short as possible. First, let's see, 1, determine if the function has an inverse. Okay. So basically that's referring to this. And then 2, replace f of x with y. Okay. 3, switch x and y. Okay. And then 4, solve for y. And then 5, replace y with f inverse. Okay. There's one more thing I want to share with this, and then one other property. I kind of want to shrink that down just to get it on the same page. It's actually really good. So like this. I'm coming, guys. I see the time. I'm trying to get you guys out of here. But I'm trying to wrap up at least this question so we can check our work. Give me just a moment. I'm just trying to get this to fit. Hopefully that's not too small for you. This, come on. And let me just redraw this line. Okay, that's referring to that. Okay. was one more thing. Inverses. What was I about to share? Inverses. We found it. Oh, okay. And then the last thing. This is another property of inverses. Property of inverses. Okay. So for inverses, the domain of f is equal to the range of f inverse. Okay. And then the range of f is equal to the domain. I know. Domain of f inverse. Okay. So once you identify the domain and range of f, that automatically gives you the range and domain of f inverse. Okay. So that was, and I could keep going, but I just want to answer the question now. Just try to wrap it up. I see the time. I'm trying to get you guys out of here. Okay. So tests for symmetry. So I think I'm just going to do a test for even and odd and use that in my test for symmetry. Let me see. Actually, I can look at it. It's not even, right? Because when you replace x with negative x, you don't get back the original. But I think it is odd because do you have x-axis symmetry? No. Yeah. So I think it's just odd, right? Because when you replace x with negative x, you'll get negative times the original. Yeah. Yeah, I'm just gonna go with odd. So it should be fine. I'm gonna say yes, I'm gonna say no and no. I didn't officially test it. I'm just trying to wrap this one up. I'm gonna hit next. I'm gonna go with it just for the sake of time. I'm gonna hit submit the test. Thank you, Anna. Stop. Let me see, did we do that one? Okay, yeah, we didn't do that one. Right, so the ones that we did, we got correct. Okay. All right, I don't know about you guys. That was and we only got through like 4 questions, right? But we only have 50 minutes together. Like we don't have a whole bunch of time. So maybe what I'll do is with my other classes, maybe I'll continue this exam, and then just encourage you all to watch the sessions with my other students, so you can at least have a more complete, you can have access to a more complete synopsis. So I'm not kind of repeating the same thing, going through the same questions. Well, actually, the exam changes, so it's not going to matter if I do a different one. Yeah. So if you want to see other questions like these demos, like this kind of presentation, which I don't know. But you can always tune into my other sessions. For you guys, you can watch my 2 o'clock, my 3 o'clock, and my 4 o'clock. Right, all 3 of those are College Algebra 1. Okay. Does anybody have any questions? While you think about that, I'm going to go ahead and make a copy of this available for you all. Okay. When this bar finishes loading, you should receive a copy of anything that you saw me writing. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, take care, guys. Happy holidays. And I'll see you, I'll see you when we get back from the holidays. Take care. Safe travels.